Hello everyone, welcome back to Wild to Learn. We are going to continue our playthrough with the next task, Heritage Protection. Good morning. We have dozens of scientific equipment placed in protected areas for the sake of looking after the objects of national heritage. We're parsing info from our equipment on a daily basis and need to sort it depending on the color of the report. Can you make a program that will help us? Okay, so this is red, green, and blue. Just divide them. Okay, pretty sure we did this before. So we just take red and blue, the colors don't really matter. And then this is going to have a mixture of red and green, so we sort them out. This is going to have a mixture of blue and green, so we sort them out. And then we just assign the correct outputs. Pretty sure we used this in one of the previous tasks, so yeah, that should work. Okay, predicting the sales. Okay, that's a short email. Hi, I have a clothing store and want to know how much money I might earn during the holiday sales. Help me. Yep, okay, direct and straight to the point. That's pretty good. Okay, we want only red and then mixture of green and blue. So, okay, let's do a balancer. Only red, we can do our usual trick of just filter out the blue and green. So that leaves only red on top. Now, this one is only going to have green, so let's put that here. This one is going to have a mixture of blue and green. So let's put that here. Actually, let's try it without the balancer. This is going to have a mixture of blue and green, but we can also do something like this. The last output we need only blue, and then here we need some mixture of blue and green. Okay, I don't think so. Maybe it's not going to be enough items or something, but we'll try it. See what happens. Okay, just not fast enough. Okay, if it's just not fast enough, we can put a balancer. Oh, I see the problem. Okay. Yeah, because if we make another copy of this, we're going to need 3 more nodes, but we're only allowed 2 more in this case. Okay, so we still need to filter out all the reds, so I don't think this is optional. This has to be done. And then, is that it? Because now we have 2 of them processing the first stage. Let's try this. Okay, we got it. Great. Next one is another startup, Gamazon. Gamazon. Hey, it's Jeff, really. I'm assuming it's like Jeff Bezos. I own a small online bookstore. I need your help in choosing a logistics company depending on a client's region and type of the book ordered. I would love to automate the process with the help of a special program. I offer you a share of sales made with the help of your system. Please note that the entire data needs to be processed. Entire data needs to be processed. I'm wondering if that means that you have the same number of inputs and outputs. Or, okay, this is not a regular task. A startup doesn't have a required number of outputs. So maybe it just means there's no trash and you have to sort everything. Okay. So you have different colors, and then the triangles are here, and this one only takes a square. Yeah, this one's a bit weird. I'm wondering if you can just ignore this one. You send all the inputs to these output streams and just ignore that one. That would be easier to sort. Anyway, let's start with the colors again because the colors are faster. We want red, green, and blue separated, all separated. So yeah, we're gonna do that, the thing that we just did. So red, green, and blue. Green all need to be separated. Okay, and then we're gonna put sift to sort out the red shapes. So red, red triangles go over here. Red, everything else go over here. Same thing with the green. Green triangles need to go over here. Green, everything else goes here. And then everything blue doesn't need a sift. We just put here. So now we should have all these outputs. This one, we'll test it and see if we can just ignore it. Okay, the outputs seem to be fine. The only thing is, I don't know if this will handle enough customers. So let's copy paste, and then we'll put a balancer. Put a balancer in front. Okay, let's test this. Okay, it's handling all the customers fine for now. Okay, now we got more customers showing up that's not getting handled. So let's try patching it and try to put another layer and see if that works. Balance that again, double the processing output. Patch. Okay, nope, we're losing money. 2203. See if we can do any more. Nope, this looks like it's the maximum processing capacity no matter how much we put. And we're losing money, so let's patch that back. So, not this. Delete this, and we'll just go back to the previous state. Okay, yeah, we're in the green again. So it looks like this is the maximum that we can do. Still making money. This is just kind of like the last startup that we did. We got an enormous amount of unserved users, but we can't seem to do any better. We just keep making money until the users disappear. Okay, we're getting there. Yep, this is the last day. We'll do that and then cash out. Okay, looks like we have more things in the C-Bay. So, Entourage, what else can we do? A Samsung X456. New generation. Okay, we got a new phone on our desk. Ooh, hardware, okay. Alright, we got the GVIDIA, increased node work speed by 5%. Rentium 3 increases work speed and data transfer. A new HDD, another DLL slot. And 1 GB RAM, increased socket processing queue by 7. Okay, looks like that's what we have here. One more cat. This is 17,000. Okay, we can't afford that. Oh, we can buy nodes. We can buy random forest or isolation forest. No more complex structure than a decision tree, but it can recognize more classes. Seems interesting. Isolation forest, anomaly detector. Okay, this is... Okay, since they have the same speed, I think I prefer using this first, because this one seems like our decision tree where it could have a split of a mix. If you have something like a blue, or sorry, if you have something that's like a green circle, which doesn't meet any of these criteria, then it could get split along the two lanes. But if we use the isolation forest, then we have a pure else clause that's going to split everything neatly between one or the other, and I think that would be easier to use. So let's use this. And then our entourage, I think this is the one that we didn't buy. That's 40,000. Oh, messy hairstyle. Shoe classic, yep. Okay. This is everything we can buy now. Okay, so we got our new Feng. And then where's the hairstyle? I guess we got a new jacket too. That's cool. Alright, let's go to the tree. Okay, next one is accuracy. Need harder ML job. Level up maybe? Hi friends, it's me again. Some people. Thanks for those jobs. I can now afford a meal almost daily, but I need a kick-butt video card to proceed with my task. Ergo, need more money. Am I ready for a more hardcore job maybe? Little coders grow up so fast. No problemo, my duderino. I'll send some more contacts your way, with bigger data too. Beware, in these tasks, you are allowed to make some mistakes, but they're way more tricky to crack. How so? This is real-life data science for you. Corrupted data, incorrect data, useless data. When it comes to big numbers, it's not about being 100% correct. It's about getting the job done. Okay, isolation forest. Yep, we have that node. We just bought it. In the game, if the element satisfies both conditions simultaneously, it goes to the upper socket, otherwise it goes to the bottom. Okay, so this is like an AND condition. Red AND circle goes up to the top. If it's just red but not a circle, it goes down to the bottom. If it's just a circle and not red, it also goes down to the bottom. Okay. In the real world, isolation forest is one of the simple algorithms for detecting anomalies. Same as decision tree and random forest, isolation forest distributes incoming items into the leaves of the trees. The fewer questions it takes to separate an element from the rest, the more anomalies it is considered to be. More anomalous. Okay, so here we just want red and green, but the accuracy is 50%. So seems like we can just do this red or green, and it's okay if some of the blue gets mixed in, because blue is going to be roughly 1/3 of either red or green, so that's okay. Yep. Okay, industrial espionage. Greetings, we hope that this message will remain confidential. We are sniffer.all, an analytics agency, and our services include parsing data from huge companies. The issue lies in their protection systems. We have a very small amount of time to download all the data before we get tracked. We need an algorithm that will download the data we need fast and secure. The payment will be sent to you after a first successful parsing completed with your program. Okay, red and blue, red and green, so the normal way to do this is green and blue and have a mixture of red, but there has to be a catch to it. Okay, this one requires 25. I'm guessing we will not have enough red in here. Yeah, we just don't have enough items. So we're gonna need to steal some red from the top layer. So let's try this again. We're gonna take, let's see, we're gonna take some of the red and any, and then let's feed the additional red into the top. So we're stealing half of the reds from here, the remaining half of the red going here and get distributed evenly. But the first half that we steal, we're gonna put it into output stream 1 just because it needs more items. Okay, got it. These are pretty easy. The invisible matter. Oh, sorry, color business. One more. Good day. We have developed an innovative printing machine that allows to apply complex patterns to any surface. It has 2 print heads. This speeds up the process a lot, but the distribution of colors does not work for us as the printing algorithm doesn't recognize them very well. We need to solve this problem before we release our novelty to the market. Can you help us? Okay, red and green, red and blue, and just blue. Okay, and then we have 2 inputs. So this seems to be a numbers game again. Let's see, 35, 50, that's 85, or, okay, 35, 55, 90, 140 outputs. I have 50 plus 60, 110. Okay, we have a little more input, so we have a slightly more comfortable margin. Let's see how we're going to divide this. This one requires 35, so how about we just send all the red up on top? Oh no. We need all the green on top. Okay, that's important. So either way, we need to filter out all the greens. So green and blue, let's try green and blue. This one, I'm thinking green and blue just because we want some of the red to come up on top as well. Let's see how many we want. Green, we have 30 green total. So after that, we only need a little bit of extra red. So maybe this is what we want to do. So this will have all the green plus about half of the red. So that's 20 plus 12. And then we're going to add another 10 green. So we're going to do another layer of processing here. I'm going to take all the red out. Okay, this will have only green from here. So 10 green, 20 green, that's 30 plus 12 makes up the 35 red and green that we need. Okay, now what else? Green, this is going to have a mixture of blue and red. This is also going to have a mixture of blue and red. I'll just put them here so I remember what's in them. And here is only going to have red, so only red has to go here. It cannot go to the next output. And it's going to have about half. Is that right? No. Yes. It's going to have about half of the red, so that's 20 red. And we're still missing 30 elements from here. If we take all the blue and all the red, that's going to be 50 something. That might be too much. This side is going to have half of all the blue and half of the red. So technically I think we only need half of the blue. So okay, let's look at the last one. Last one, we need 55 blue. 55 blue. So we need the vast majority of the blue. What if we take, let's see, half of 36 is 18 plus 37, that's barely enough. Okay. Let's try blue and any. We're gonna get half of the 37 blues to go in here. We'll send the rest over here. And then up on this tree, we're going to take, this is a mix of red and blue. The red we're gonna put all in here. The blue we're gonna put all in here. Let's test that. Oh, we're like missing one. Like missing one. Okay. Maybe we want to shuffle this a little bit differently. What if we did blue any and blue red over here? Because this one has slightly more blue, just one more blue. I'm hoping the one more blue is going to get, well, it will get a sign over here. And that'll make up for the difference. Nope, still missing one. Okay, so we're gonna need to do... We might have more time, so we might be able to just add one more node or something. Alright, it turns out we almost had it. The thing is, over here in output stream number 2, we were getting 40 red plus half of this, which is already 54, which is already more than we need. So we don't actually need any blue to be shuffled in here. So if we just change this lane to receive all the reds and then put all the blues down here, then yep, that's enough. That's all we needed to do. Okay, last mission, the invisible matter. Hey there, I am an inventor and I've spent years trying to create a new generation stealth suit. I plan to call it the Cry Suit. Really? Really? I've certainly cried a lot while working on it. I think I'm on the verge of a breakthrough, but the particles responsible for dynamic color adaptation can malfunction occasionally, and the camouflage is still far from being perfect. Can you help me write an algorithm that will improve it? And can your computer run it? Alright, just red and green, blue, and red, just normal filtering, I guess. So we want blue in one direction and green in the other. I'm just gonna try this first. I don't know if it's gonna work, but let's try it. Okay, a little bit too slow. I mean, we could just process them in parallel. It's not a big deal. Okay, that was a lot easier than I expected for a task that's all the way out here. Alright, so that'll be it for the gameplay portion of this episode. We are going to continue with some discussion, but if you're not interested in that, then feel free to skip to the next episode. Next time we come back, we will do the next task, solvency assessment. In one of the conversations we saw in this episode, our character mentioned needing a graphics card to perform their machine learning tasks. This is quite realistic. The calculations used for machine learning algorithms are usually very simple. It's just adding and multiplying numbers. But the same type of calculations usually need to be repeated many, many times. As an example, we've talked about neural networks before, where each neuron just sums up all its inputs with some multiplication factor. So the calculation for each neuron is just multiplying then adding, but there might be thousands of neurons or more, and the calculations need to be done for every one of them. This is the kind of task that GPUs are really good at doing and can do much faster than CPUs. GPU computing is used very widely today for lots of scientific calculations for that reason. Beyond GPUs, there are also specialized processors that are designed to run specific machine learning algorithms. Google's Tensor Processing Unit is one example, and it's used to process the neural networks behind DeepMind's AIs, including AlphaStar, which we talked about previously. Because they're specifically designed for these tasks, they can do them significantly faster than even GPUs. And that'll be the end for this episode. Hope you enjoyed, and see you next time.